In today's lesson, we are going to learn how to solve a trinomial of the form of ax²+bx+c. But if you look at the leading coefficient, the leading coefficient is not 1 anymore, it's a. So, as usual, what we are going to do is we are going to try to factor the polynomial using the common factors. So if after the common factor the trinomial becomes x²+bx+c, meaning the leading coefficient is 1, then we will try to use the sum and product method. Hopefully that's going to solve the problem. But if even after common factor the leading coefficient is not 1, then we are going to use another technique. What we are going to do is, hopefully, this is going to solve the problem. We are going to find the product of A and C, the leading coefficient A and the constant. We are going to find the product of those two numbers, and then we are going to find all the factors of that product and see which one gives you a sum of B. If we can find those two numbers, hopefully, then we are going to break up the middle term, which is b, bx, into two terms. mx, which is one of those numbers that we found, and nx, which is another one. And then we are going to use the grouping method to factor the trinomial. It seems to be a little bit confusing, but the process is very, very simple. In fact, this process is exactly like what you did before with sum and product when a is 1. Now that a is not 1, we are going to find the product AC. And that's the only difference between this method and the previous method. So let's show how the process works with a few examples. The first example, we have to find the factors of 3x² plus 17x plus 10. You can see that there is no common factor, so we can't do anything, and also the leading coefficient is 3, so we can't use the sum and product. So what we are going to do, we are going to find the product AC, which is going to be 3 times 10, which is 30. Now we are going to find two numbers that the product is 30, but the sum is 17. With some try and error, you can see that those two numbers are 2 and 15. The sum is 17 and the product is 30. So I can break up the middle term to 2x and 15x. So I'm going to write 3x² plus 2x plus 15x plus 10. So now I have a polynomial of 4 terms instead of 3 terms. But now I'm going to use the common factor and factor 3x² plus 2x. The common factor is x, so I'm going to get 3x plus 2 plus the common factor between 15x and 10 is 5, so I'm going to get 3x plus 10 plus 2. And if you look here, this term and this are common, so I can take 3x plus 2 out, and I'm going to get x plus 5. That's all about this technique. Very simple and straightforward. So let's do another example. The question is that factor 3x² plus 8x plus 4. So again, there is no common factor between 3, 8, and 4. and the coefficient is other than 1, so we can't use the sum product method. So I'm going to find AC, which is 3 times 4, which is going to be 12. Now I have to find two numbers with the product 12 and the sum 8. Those two numbers are 2 and 6. So I can break 8x into two terms, 2x and 6x. So I'm going to write 3x squared plus 2x plus 6x plus 4. If you have noticed, is the order that I break the middle term does not matter. I can write it as 3x squared plus 6x plus 2x plus 4, or 3x squared plus 2x plus 6x plus 4. Still, it's going to factor out by grouping. You can try it yourself. So again, I'm going to take these two terms and these two terms. The common factor is going to be x, so it's going to be 3x plus 2 plus the common factor of 6x plus 4 is 2, so I'm going to get 3x plus 2. Now this and this are common, so I'm going to take 3x plus 2 out, and I get x plus 2 here. Now to show you that the order doesn't matter, if I write this one as 3x squared plus 6x plus 2x plus 4, again I do the same thing. I take these two terms and these two terms. I can take 3x out here. I get x plus 2 plus, I can take 2 out, so I get x plus 2. Now x plus 2 is common. If I take x plus 2 out, I get 3x plus 2. You can see that I get the same factors here. It doesn't matter how you write the middle term. Let's do another example. Three x squared plus 2x plus 4. Again, there is no common factor, so I can't use the sum and product. So AC is going to become 3 times 4, which is 12. Now I have to find two numbers with the product 12 and sum 2. The numbers that gives you the product 12 are 1 and 12, 2 and 6, 3 and 4. And as you can see, if I just add 1 and 12, I get 13, 8, and 7, and none of them gives me 2. And since the product has to be positive, I can't change the sign, except if I make everything negative now. And if I add it, it doesn't give me a positive number. So this is telling you that this trinomial is not factorable over integers. So that was an example that not all the polynomials are factorable. The next example is 6x squared minus 5x plus 1. Again, since a is not 1, I can't use the sum product method, so I'm going to find AC, which is 6 times 1, which is 6. Now the question is that find two numbers that the product is 6 and the sum is negative 5. Those two numbers by trial and error are negative 2 and negative 3, so I can break up the second term into negative 2x and negative 3x plus 1. Now I take these two terms together. The common factor is 2x, so I get 3x minus 1. And here I take negative 1 as factor, so I get 3x minus 1. 3x minus 1 is common, so I can take 3x minus 1 out, and I get 2x minus 1. the next example, again I have a trinomial. There is no common factor here. Leading coefficient is not 1, so I can't use sum product method. So again I'm going to say AC is equal to 10 times negative 4y squared, which is negative 40y squared. So again, we have to find two numbers that they multiply to negative 40y squared and they add up to negative 3y. So by trial and error, we find that those two numbers are negative 8y and 5y. Because negative 8y plus 5y gives you negative 3y, negative 8y times 5y gives you negative 40y squared. So I can write 10x squared minus 3xy. I'm going to write it as negative 8xy plus 5xy minus 4y squared. Again, I take these two terms and these two terms. The first two terms, the common factor is going to be 2x. So I get 5x minus 4y plus the second terms, they have y in common, so I take y out, so I get 5x minus 4y. Again, these two are common, so I get 5x minus 4y and 2x plus y. The next example is to factor 10x squared plus 20x minus 12. Again, the common factor does not exist, or I'm sorry, the common factor exists at the moment. The common factor is going to be 2. So I can take 2 out, so I get 5x squared plus 13x minus 6. There is nothing else common, but the leading coefficient is not equal to 1, so I can't use the sum product method. Again, AC is equal to 5 times negative 6, which is negative 30. After some trial and error, that we find that the two numbers, that the product is negative 30 and the sum is 13, is going to be negative 2 and 15. So I can write the middle term as 5x squared plus 13x, let's say 15 first, and then negative 2x minus 6. Now if I take these two terms, the common factor is going to be 5, so I get x plus 3, and also I can take x out, so it's 5x times x plus 3 minus, I take 2 out, so I get x plus 3 again. Now x plus 3 is common, so I can take x plus 3 out, and then I get 5x minus 2. Or I can write this one as 2 times x plus 3 times 5x minus 2. So that's going to be my final answer.